Welcome to this new video dedicated to simulating a CPU. Today we are going to talk about simulating a control bus. If you watched the first video in this mini-series about CPU device, you surely remember that CPU, besides data buses, also has control signals, and we can think of those control signals as a control bus. So each line on this bus corresponds to a specific signal. If you didn't watch the first movie in this mini-series, then you should probably pause this one now and watch Simulating a CPU Part 1. Assuming you watched the Part 1 and probably Part 2, which discussed generic CPU simulation, now let's take a closer look at this control bus. Actually, a control bus may exist also between other devices, not necessarily involving the CPU. However, I'm discussing about it here because every CPU will need control signals. So this is a generic simulation of a control bus. It extends also the generic device class. So the generic device allows configuring and initializing the control bus, and the control bus specifies specific methods for setting signal, clearing the signal, checking if a signal is set, but also for certain applications it may be necessary to have some additional data associated with a certain signal. In a specific device, this data can either be present on dedicated data lines, or in the case the signal is set, some additional circuits take care of placing this data directly on the data bus. But for simulation purposes, if such additional data is needed, it can be specified directly on the control bus by using these two additional methods. In all the methods, it's possible for the control bus to throw a control bus unknown signal exception. Of course, depending on the actual implementation of the control bus, in a simulation it can accept any signal, and in this case it will never throw an unknown signal exception, or the available signals may be either hard-coded in the control bus implementation or specified via configuration settings in the simulation JSON file. Let's take a look at an actual implementation in the Java Assistant Simulator project. It's called Control Bus Basic. What it does, it has a hash map with the available signals and another hash map for the signal data. I want to remind that signal data is not always used, and it's actually used in very few cases. As I said, the configure method is in charge of reading configuration data, and in this case, for this implementation, it will read JSON setting called signals, which will contain comma-separated list of signals that are available on this control bus. The initialize method will simply put boolean false for each signals, and will also place null for data. In theory, it may be possible to have certain implementations where it's needed for certain signals to be set in the beginning, so to have value true. But currently this is not implemented as part of this control bus basic implementation and needs to be handled some other way in the simulation. The set signal method in this case is very simple. It will simply check if the signal is available. If not, it will throw a control bus unknown signal exception. And if it is available, it will set it to a boolean true. The clear signal is similar. It will set the signal to a boolean false. The isSignalSet method will return the value associated with the signal, so it can be either boolean false or boolean true. And set signal data and get signal data will use the other hash map and either set the data or retrieve the data and return it. So again, if we take a look at this interface, it's a very simple one. Probably this implementation is not very optimized, and it's possible to use something else apart from hash map to make it run a bit faster. But for most purposes, it works very well. And the most important advantage of this implementation is that it allows specifying the available signals in the JSON file associated with the simulation. Again, from the previous video in the Simulating a CPU mini-series, you probably remember that an actual CPU device also implements this generic control device interface, which allows attaching to a control bus. So in this case, the simulation engine will call the attached control bus method with the specified control bus is indicated in the JSON configuration. I hope this clarifies how to simulate the control bus in the Java System Simulator. Thank you for watching. Bye.